Hello everyone. In this short video, we are just going to learn how to locate the ICR of a roller either rolling on a surface without slipping or when the roller is rolling on the surface with slipping. So I have two rollers over here. I will be explaining one for the roller without slipping and the other one will be with slipping. So let us have a surface first of all. This could be acting as a horizontal surface for me from where the roller is rolling. Now one thing you have to note that it is rolling without slipping, which means that this roller, whenever it is having the contact with the surface, there will be no velocity, no relative velocity whatsoever, which means that this roller is exactly as at a steady position when it is in contact with the surface at this given point. So in such a case, we can assume that the entire roller is rolling around or rotating around this particular point for this given instant. At the very next instant, let us say if this point is taking over here, then this point will become the point of rotation for the roller, which we may assume it to be rolling or rotating over the surface. Now, if I want to find out the velocities at any given point in this roller, for me I have to locate first of all the ICR. So for me this particular roller will have the ICR over here. Why? Because the roller is completely as at a steady position when we are taking in concern with the horizontal surface. So I want to locate the ICR, the velocity of the center of the wheel. Then I will just draw a perpendicular line. I will just join the center with the point and draw a perpendicular line from there. So this is nothing but the velocity of the center. Let me call the center as C, and this is the distance. Definitely this will become the radius R and so on. So this becomes the ICR for me for the entire roller. Now if I want to find out the velocity of any other point on this given roller, it could be maybe the topmost point of the roller, D. So again what I have to do is just join that with the help or maybe from the ICR and draw a perpendicular from there. This perpendicular will be nothing but the velocity D. This was VC. Same way if I wanted to find out the velocity at this given point, so what I have to do is again just draw a perpendicular, and in fact join these 2 points and then draw perpendiculars from there. So here I'll just try to draw perpendicular from this given line. Let me name this point as E. This becomes VE, velocity VE. So I hope you people have understood this part, which is the ICR location for a rolling object without slipping. So I'll name it over here, rolling without slipping. Now we'll go next on towards rolling with slipping. So in such a case what happens is I may have a horizontal surface over here and the roller is rotating around its center, no doubt, but at the same time it is also moving at the same time with the horizontal surface. So this kind of a situation arises when we have a, let us imagine a tire wheel which has taken velocity or which is moving at a greater RPM, but it is not able to just move the car ahead. So in such a case we may consider this particular situation as either skidding or maybe even the velocity of the entire roller is more than that of that which it was supposed to be with respect to the ground. So in this case this point now is no more at rest. This point is also moving. Let us say it is moving in the backward direction at some velocity. So I'll just consider the velocity or draw the rather velocity over here. This is the velocity of that given point, and the other point which is at the higher part, maybe it is also at some higher velocity. So I will be drawing the velocity of this point given, but that is at a higher velocity, so I will be drawing that velocity a little bigger. So let me name these points as A and B. Over here, one thing you have to note is that even the center is moving. So if I'm locating the center also will be moving with respect to A and B. Now how to locate the ICR for this given roller? As we know, ICR can be located by just getting the intersection of two lines which are perpendicular to any two known velocity of a given object. So in this case, I know the velocity VB and I know the velocity VA. But the problem is that if I'm drawing the perpendiculars from both of them, the perpendiculars will come and meet each other over here in this way. So where is exactly my ICR? That is the question. The ICR over here in such cases cannot directly be located. For such a case, I may have to know what is the velocity VB and the velocity VA. Most likely it will always be given in the problem. VB and VA, generally they will be given in the problem. So with help of geometry, I can actually consider or may assume that VB is of a particular length proportionate to that velocity, and VA is that proportional length or proportionate velocity with respect to the velocity given. So here I will just try to draw a line which may represent my velocity vector, and this line is representing the velocity vector VA. And now what I have to do is I will just try and join their heads. The point where they are intersecting with my perpendiculars drawn is the point called as ICR. So this point over here becomes ICR I. Now using this ICR, you may be able to get the direction of any of the velocity and their respective values. So let us say in our case, if I am trying to find out the velocity VO, I can find out velocity VO by just drawing a perpendicular from point O with respect to I. Same way, any other point on this given sphere or the roller, I can actually just draw the join that point from this ICR. Let me call this as VD and draw a perpendicular from there. This will be giving me the velocity VD perpendicular from this given line. So this was all about rolling with slipping. So I hope you have understood well enough for the cases of rollers. In the next lecture, we will be starting with our regular problems. Thank you.